Thanks, everybody. We got a really jam-packed session for you guys today. We got a lot of good information that we want to impart. So just a couple of quick things. We're here today to talk about an effort we're working on with the U.S. Navy at a Space War Systems Center Pacific around how do we modernize software development, including the inclusion of DevSecOps, right? So the idea of DevOps processes, accelerating the software development lifecycle, but then building security into that. So with me today, I have two other speakers who are going to be kind of leading you through this journey. So up first is going to be Rick Jack, who's a distinguished software engineer from the Space War Systems Center Pacific. I'm going to go ahead and get him up here now, but before I do that, I just want to let you know we have a lot to cover. So we're all going to be hanging out outside the room after the session for questions. So with that, I'll turn it over to Rick.
Thanks, Rob. Boy, I studied all my lines for the Book of Mormon, and I'm really sad we never got to get to that. So maybe later we'll give you a little bit of an excerpt from that. Rob asked me to come here and help paint a picture of what we were doing with the Navy with respect to trying to take advantage of all the partnerships we have and these strategic capabilities that we're trying to achieve. And so, ultimately we're really trying to speed capability up, ensure we optimize things as we go. So, I work for a science and technology research laboratory, and the CNO had put out an initiative that says, hey, we really need to move faster. This idea that we have these antiquated processes needs to be updated. We need to figure out ways and opportunities that we can ensure we're meeting this idea of what we call speed to capability. And unfortunately, as I look at these slides, I think, God, am I painting a picture of doom and gloom? I don't want to come off as doom and gloom. I do feel, I'm very, very proud that I work for the Navy. It's what I feel is the most capable Navy in the world. We have a lot of technological advancements that are way ahead of the game, but I see it as my job to ensure we keep that competitive advantage. In order to do that, we kind of have to take a hard look at some of the seam issues we have and some of the things we're trying to tackle with respect to what we're doing. So we do have to understand that, as we have to play a little bit of armchair quarterback, look backwards in the lens and understand that, monolithically building Navy ships comes with some challenges that the Navy has because we forward deploy, the way we have these very structured processes in place, that over time we've kind of had some things we have to overcome. Mostly it's revolved with this idea that we have some systems that, although are capable, sometimes have some interoperability challenges. They're somewhat complex, and that when we really want to expand the capability, sometimes there's a challenge with making sure System A talks to System B, or we have logistics systems talking to weapons systems. Those kinds of interactions, although can work, they just don't happen at the speed we need them to happen. So what we're trying to do is create a lot more of a interoperable, a more flexible environment. We do this, so one of the challenges we had is this idea that the capabilities and the complexities we have give us less visibility into the true status of the infrastructure and what we're trying to achieve. At the same time, that complexity actually adds to the speed for which we can deliver our capabilities. We do have to ensure we're not taking undue risk. My biggest concern, I do not want to put anybody at risk. That's unacceptable to me to put somebody in harm's way just because of some issue or flaw that we didn't see. So because that, there's a lot of these very rigid processes that have to look and examine and ensure we don't take on those risks. But if we look across at what industry is doing, we can look and see how we can modernize those techniques, really take a second look, crack the egg, and see if we can speed capability up by leveraging technology. This obsolescence, this idea of moving super slow also drives up our costs, and we're trying to address that also. So we try to, let's take a look at this from a very basic perspective. What we found is we had this lack of shared infrastructure. We had a lot of data centers out there. Those data centers weren't necessarily fully connected. We had these isolated domains of information, and integration and staging tended to be a little bit disconnected. So what we're trying to do is break down those barriers. We also had duplicative investments in infrastructure. We were kind of all doing the same fundamental things. And the same fundamental things kind of go all the way down to this idea of the infrastructure. So capabilities, when they come aboard, they assume, oh, I have to bring networks and switches and routers and computers and software and parts of the stack that maybe another system also do. So we had to take and really push the enterprise service approach. The other part of this is we're fielding capabilities and understanding we're finding defects too far down the line. We've learned from Sec DevOps that the idea is don't pass defects down the chain, but ultimately security has been one of those things we put at the forefront where we need to do a little bit more refocus on with respect to security. This is why we're really keen on adopting a Sec DevOps principle. Because we want to ensure software assurance is something we adopt throughout the entire life cycle of the software. So, some things we're doing in order to shape the strategy. So, with Don CIO and the CIO really pushing this idea that we need to rethink about the way we do software, which is we have these pillars, these ideas. One is this cloud-first strategy. At first, everybody's like, oh, well, this is a concern. For me as a technologist, I'm thinking, wow, this is a great capability. How does it bring to bear the things that we lacked before? And this is the idea, this idea that we can spin resources up, we can be super fast, we can be super efficient with respect to elasticity and scalability in the latter part so we can optimize in the front side of the equation. Right? So if I have to do an event or do a test or evaluate or do some optimization, I don't have to wait. I can easily spin these services up in the cloud. So this cloud-first strategy is something we've embraced wholly. Also, this idea of enterprise alignment. Now that we have the cloud, we can start to synergize the enterprises between logistics and services and the weapons capabilities. All those like services we can start to adopt and really economize. We can also really push the boundaries of where we want to go with AI and machine learning. We know that the Navy can't do this alone. We have strategic partnerships that we need to take advantage of. We are behind the curve. 98% of the brain trust, 98, I would say 99% of the brain trust is here in these consortiums, right? Between the cloud service providers and the capability providers. So that AI and machine learning, you guys have in spades, and we need to take advantage of that in terms of those capabilities and roll those in and see how we can enhance our ability to deliver. In order to do that, we have to kind of make some hard decisions with respect to architectural frameworks. Right now, it's a little bit disparate, not horribly, but a little bit disparate, but we are starting to synergize this idea. And the reason we're trying to synergize the idea of this architectural framework is speed. So if we can create some commonality, we can really start to adopt this concept. We've kind of labeled it what we call compile to combat, which is this idea that we can expedite capability very quickly. We call it compile to combat in 24 hours. It's a very high bar. I appreciate what Admiral Barrett was doing there. She really set the bar high, and we tried to answer that call by saying, ultimately, I think we can if we take a hard look at one, adopting secure frameworks. Two, leveraging what industry has already done for us with providing a secure starting point, a secure baseline, a secure platform. And then ultimately, with that platform, define an infrastructure that makes the most sense in a common way, and then let our capability providers adopt those, and then we can speed the capability up. The second part of this is allow that capability to actually roll through a set of definition services that we can kind of evaluate and understand the risk as we go to ultimately get to a point where the decision makers don't feel like they're in the dark. They ultimately know the bar for which they're trying to achieve, and the software as it goes through this, what we call a software factory, has given us the visibility into it. And so we can make those decisions on whether we're willing to release it or we just want to kick it back. And we did this in several experiments we've already taken advantage of. The other side of the equation is once we get the capabilities, we're trying to define standard data formats, data sharing specifications. We're really adopting this idea of adoptable frameworks with respect to data standardization, and data ontologies, so we can share between domains, between the IC domain and the other domains. And then Sec DevOps is a principle from the starting point, starting from the idea of conception. We're really starting to kind of crack the nut on well, what does a user story look like with respect to security? You know, as a hacker, I want to kind of thing, and driving those requirements up front and sharing them between our broad collaboration of warfare centers, so we kind of set the bar at the same level, and then you can rheostat it yourself depending on the idea of how important you think it is, right? So obviously a satellite or a weapon system is going to have a lot higher bar than, say, maybe a website that just is information and tells you when the next barbecue is. So, but we understand that. Not everything's at the same level, but you can set that bar fairly high as long as you're willing to adopt this idea of automation and compliance. We're trying to get to is this idea of both automating compliance, taking advantage of the services as provided, really moving fast, and working very closely with you guys to understand that you're part of the equation. So, in order to do that, I'm going to turn it over to Phil Osip. Sorry, Phil Osip, who's a part of our team, and he's been working very closely with us. I'd like to introduce Phil Osip from Red Hat.
Thank you. Okay, speaking of agility and speed, I'm going to be jumping through a lot of slides quickly, but the decks will be provided afterwards. I want to start the conversation. So Rick set the temperature for the operational needs for speed and alacrity with security, with optimizations, doing more with less, and with having a cloud-first mentality, being able to not just be cloud-ready, but cloud-enabled and cloud-native where it makes sense, but support a hybrid cloud model because the afloat systems aren't always connected. What I want to start with is dispelling some myths. We've seen the Venn diagrams of DevOps, and we look for that intersection point between them. When we bring security into the equation, all too often we get pretty views like this that are pretty but wrong, because what they're looking for is this tactical point of intersection between security concerns and DevOps concerns. The reality is, security encompasses all of it. It actually starts beforehand if we're doing it well, if we've bought into shift left, we're doing things earlier in the life cycle. If the operational user stories that we're conducting are, as an assessor, I need to evaluate XYZ so that I can provide an ATO, we're already culturally bad, culturally doing it in a suboptimal fashion. If instead, as a developer, I need to include these security compliance checks so that my code can get checked in, so that the build will run, we've moved and shifted left the responsibility for the same things you need to do, but with a baked-in versus a bolted-on mentality. So what does that look like? AWS, Red Hat, we have our own pretty pictures that show a secure DevOps lifecycle. Rather than self-advertise one of those views, we're going to walk around something that came out in 2016 from Carnegie Mellon. And it's a secure DevOps lifecycle. And what I want to orient us towards is what's the approach that we took to meet each of the stages as iteratively moving around this lifecycle. First off, identifying how to shift left with security and information assurance. And it's really all about treating security as a quality attribute. 10 to 15 years ago, we'd have the arguments on the benefits of unit testing, of test-driven development, of code quality checks. Those are baked in at the IDE levels now. So we've shifted that all the way to the left, and we don't make that part of a build and inspection. You can do those inspections still within an automated build lifecycle. We're talking about doing the same things with security attributes. How do we do that? You start off by identifying what security means before you start. That means you need to know, what are you being held to as a standard? Is it a FedRAMP moderate posture, a FedRAMP high posture? Are you impact level 2, impact level 4, impact level 5? If you don't know which boxes you need to check from an assessment perspective, you can't bake in the security checks and compliance checks that are required to be able to actually add agility. You effectively still have something, a toss over the fence event, rather than an iterative inclusion of security compliance checks where they make sense as early within that software development lifecycle and within your CI/CD pipeline when you're inside of an automated build engine. Oops. Second thing is, it doesn't require a big upfront design, but we don't want organizations starting from scratch. To Rick's point, you don't want to have a bunch of snowflakes. You identify common boundaries, common pieces, architectural provisioning from an infrastructure level, from a platform level, so that you've got reuse. And we're not just talking reuse of capability or code or reuse of tools. We're talking reuse of artifact inspection, reuse of compliance audits that have already happened at those lower levels. So what does it look like to adopt a security inheritance model? This is the point where you've actually taken the information that identifies what needs to be done, and you've built that in as infrastructure, as provisioning early in the process, so that application code, as it onboards through the system, is already inheriting that goodness. We can call it a secure software factory or a trusted software supply chain, but we start with the concept of everything as code. By recognizing the capabilities today, technologically, to be able to embrace infrastructure as code, compliance as code, configuration as code, documentation as code, the actual software code for the application as code, we can leverage automation to be able to build out a common reusable stack for pipelining through applications and for establishing adherence to security compliance framework requirements. So we start with Ansible and Ansible automation, Ansible Tower automation. Basically a ubiquitous automation engine that allows us to, in the same way, with the same language and the same approach, build out the provisioning of the infrastructure, add the provisioning of the platform as a service, add the pipeline provisioning, and then run things through. And that's what we're going to be looking at in the next few slides. We start by provisioning with Ansible playbooks and put AWS EC2 instances, S3 buckets. This is where we get defense in depth with network ACLs, security groups, public-private subnet configurations that allow different things to either support a multi-tenant model or individual clusters per application owner that adhere to the same policy-driven model for deployment. After that, a second set of playbooks leverage the utilization of Red Hat's OpenShift container platform. So when Rick was talking about alacrity with security, it's really a paradigm shift from a rebuild as you move through your dev, your test, your sit, your UAT, your staging processes. It's a reuse. Best case scenario, if you're checking the boxes, with a container approach from a container platform, you're essentially reusing an immutable image that if it passes muster at step 1, it moves to step 2. If it passes muster there, it moves to step 3, and so on. The only time you have a delta is when there's a deficiency addressed, and then that's a fail early, fail forward approach to being able to address the deficiency and be able to save time, money, and manpower in addressing it rather than waiting for it to be an after deployment test event. On top of that container platform, you need tooling. We've had a opinionated vignette for the pipeline, not a prescriptive vignette in that thou must use these tools. It's that these tools have been utilized and deployed so that you get the ability to take discrete snapshots of particular security compliance checks, whether that's SAST, static analysis security tests, whether that's vulnerability assessments, whether that's image scans or binary repository management scans of the artifacts that build out the applications. And then ultimately, we exercise that trusted software supply chain by pumping application code through. And as it checks the box in an automated or a human-in-the-loop manual, and I'll deal with that in some of the follow-on slides, because, again, the Navy doesn't automatically trust that just because we can flip bits and make things automated, that means it's passed muster. So there's often opportunities to start with a manual inspection. And as trust is built, you change the pipeline configuration to be able to automatically validate rather than human-in-the-loop validate results so that it can progress. This ultimately provides a security inheritance model. And the impact here is that the individual application owners are not responsible for all of the compliance checks and requirements. All of the 800-53 controls aren't inherited per application, per pipeline run. The enterprise level services, the commonality that Rick was discussing, builds a foundation, defense in depth and infrastructure pieces from AWS GovCloud utilization, again, with public and private subnets, network ACLs, security groups. The provisioning of that provides lift and commonality, again, where you don't have to check those boxes individually at the application layer. The container platform with immutable images provides another level of discretionary inherited controls so that the application controls themselves for the individual applications running through the pipeline are a slim amount on the overall set, and that means that you've added agility. So you've made it faster to deploy without losing the secure posture of what's being deployed. So ultimately, for those that are familiar from an agile perspective with SAFe, with scaled agile framework, you've got an infrastructure in place that's maintained how you're building, loading, scanning, and how you're adopting and utilizing the images that are available for container deployments. And then you have individual development teams, release trains, running through a particular pipeline iteratively through execution for deployment and monitoring of an application. The next step is only introducing approved elements. And this happens at the code level, the binary level, and at the image level. What that means is containers start with quality parts. By having a container platform that provides build routes, certifications, signing, pre-scored, pre-scanned images to build and base off of. By having binary repository management systems like JFrog Artifactory, like Sonar type Nexus. There's the capacity for not just treating code as code, but treating those binary artifacts as part of an application deployment and being able to provision and policy enforce where you get them from, how you use them, and how they're updated. The same thing's true for code. The process starts actually pre-code review all the way on the gray on the left on the developer workstation. The best shift left focus doesn't even include anything we've talked about in the cloud. It's back at the developer workstation saying, if we can do pre-commit, pre-receive hooks, if as you check in code on your branch as a developer, you run security compliance checks, even if they're simplistic, to cover some cases, open passwords, things to that nature. You've already cut down the life cycle of finding and evaluating and fixing that bug or defect later in the cycle. Then we automate what we should, but we don't automate everything. There are things where decision-making processes require human-in-the-loop interaction. Code reviews are one of those things. What we're identifying here is a requirement to have a security-focused review criteria. So when you're getting multiple eyes on, whether you're using a GitHub or a Bitbucket or a GitLab repository, that pull request or that merge request that goes in can be configured and should be configured so that individuals can't do direct check-ins. Individuals submit that pull request and merge request, and you have other eyes on. That's the opportunity for that Scrum team to truly be multidimensional, for a security or IA person to be validating and looking at the code with an eye to security. Once we've passed that manual code review, we move on to automated security testing, whether that's binary scanning, image scanning, static code analysis, from a security perspective, SAST, static analysis security tests. And this is a description of an active pipeline with a manual promotion gate that says, I've run my SAST test. evaluate the results, and if they pass muster, continue. So we run that SAS test, we evaluate the results, we continue on, and then we utilize the policy provisioning inside of the OpenShift container platform to say, now that that code can be used, we will direct it to build out an image that we can then, before we've ever deployed it, set routes on it, made it available for consumption either internally or externally, we're going to scan that image itself. Even if it came from trusted sources and the code looked good, let's build it together as a deployable package and make sure it's good to go. So we run an OpenSCAP image scan from the pipeline directly, and this could be using other tools as well. What we've done, again, from a non-prescriptive but opinionated pipeline, is using the built-in capabilities of OpenSCAP within the container platform. We evaluate the results, we see the 99% number, it looks really good, we're saying we're good to go, and we continue on in the pipeline again. That compliance check can be a stoplight check that's human in the loop, or can be automatically evaluated. From that point, we move on to other secure artifacts, treating compliance as code. This is where we've got that immutable image. It's in our image registry in the container platform, and we're going to deploy it out into a staging area, whether that's for dev, or for sit, or for UAT, and we're going to run vulnerability assessment tests against it. That's where the outside systems are hitting against it to be able to identify defects. Again, manual promotion gates available for running the scan, evaluating the results, and I know this is a hard one to see, but there's no failures and all good passes and a couple of warnings. That is evaluated, the pipeline continues on, and then we move to more security testing. And this is really where the staging capability, that ephemeral nature of the environment within a container platform within the cloud, lets you spin up and spin down on demand. So the things that you were doing for your vulnerability assessment test and test can be spun down, or you can maintain them for another application coming through against different criteria, and you spin up other instances or other clusters entirely to be able to do things like performance testing, fuzz testing, or penetration testing against the things that came back from vulnerability assessment. We're really identifying an iterative cyclical story to take application owners and their applications from code to capabilities. It starts with development and the developer workstation. It moves into the cloud environment from a build perspective with dependency management checks, image scans. It moves then to deploy, not deploy from a CI/CD deploy to production, but deploy from a container perspective of deploying that immutable image and then banging against it externally, and then moves into the different test cycles itself. At that point, we continue to build trust and automate when the customer is ready to automate those additional checks. And what that looks like is a completed pipeline, all green, good to goes, with product-based artifacts at each of those stages, an audit trail of logging of all of the events that have taken place, so that from a security and IA perspective, you've got a nice, baked, packaged set of artifacts to be able to evaluate or to be able to use from a review process. That then takes us to how do we go from a CI/CD, CD being continuous delivery, into a production system, where production systems for the Navy's case, in some cases, depending on what the need is and what the deployment topology is, it could be a production environment that's in the cloud. For other cases, it could be onto an aircraft. For other cases, it could be to an afloat system. So there's a need to be able to physically, logically separate out the push or pull of those signed and secured immutable images from the cluster that's running the pipeline to the cluster that's running on the external system, whether that's the afloat system, the aircraft, or another cloud cluster that's hosting the production environment. It's a physical, logical separation from pre-production to production. Then all the iterative secure deployments that run as fast as you want are effectively useless from an operational and management perspective if you have no day 2 operation story, if you have no way to identify CM drift, if you have no way to identify monitoring and automated compliance checks and compliance adherence. So we have Ansible Tower, that automation engine and provisioning infrastructure, provisioning of infrastructure, platform, and application, is capable of, at a scheduled periodicity, at push button periodicity, being able to check compliance, remediate failure for compliance, and maintain consistent states both in the pipeline clusters that run in the cloud and onto the afloat systems or the external production systems themselves. So you end up with a maintained, orchestrated set of common infrastructure and common platform capabilities leveraged in release train pipeline execution for application code that takes you all the way from developer workstation through cloud automation to ship deployment to day 2 operation monitoring and maintenance. At this point, I'd like to turn it over to Rob Nolan to really tie together the operational challenges and needs that Rick spoke about, tied to the approach that we've identified and implemented, and identify the path forward from a cloud perspective for that DevOps and secure DevOps.
Thanks, Phil.
Sure.
One of the cool things about my job is I get to be the following on act to really smart people like Phil. It's tough to go on after that. But I wanted to just talk a little bit about how using cloud can help accelerate some of the work that Rick has outlined the Navy needs and what Phil was talking about. When you talk about DevOps, you're talking about a framework of processes, right? You're not talking about installing a software package or using a tool. Tools help enable you to include dev and DevSecOps into your application, into your development process. But in order for that to work, you need consistency. I can't have my application, as it goes through its life cycle, going through multiple labs that are different, right? And every single time I have different software packages, I have different OSs, I have different hardware potentially, right? So you need consistency as much as possible. You need infrastructure as code. You need the ability to deploy an environment the exact same way every single time. You need agility, right? If I decide that I want to run 10 of my environments in parallel to test communication between multiple instances, I can't wait 6 months for someone to go get hardware for me. I need to do that today. I want to iterate quickly. I want to deliver capabilities faster. And I need scalability. I need the ability to have multiple people working in parallel. To adopt DevOps frameworks and use things like Agile software development, I have to do things in parallel. I can't have serial work and everyone backed up because I don't have enough hardware, right? And then when you start layering in the security portion of it, consistency, again, is vital because I need to make sure that every test is exactly the same, that I have artifacts that describe the environments that my application was tested in so that I can understand the security posture. So in the future, if I do find a vulnerability, it's a lot easier for me to backtrack into where that vulnerability got introduced. Was it from infrastructure? Was it configuration? Or was it code? Phil hit on a really key point in his secure DevOps lifecycle, which is a secure environment to build in. A lot of times, we all think about these things, but do we really have the time to spend on secure dependency libraries, right? Do all of you scan your Maven repositories, right? Where's your upstream dependencies coming from? What are your master images like? How much effort do you have to put into scanning and building master images? So having a secure, pre-accredited environment for developers to just introduce their code into is vital. And then finally, visibility, right? Everything that you do inside of OpenShift and everything that you do inside of AWS is instrumented in some shape or form. So this is information that you can take and pull into your secure DevOps process and get, again, more telemetry, more data to help make this automation something that you can get someone to sign off on. A lot of times, I'm sure everyone in here will agree with me that IA and security is much more about checking boxes than it is about actually putting security in your applications, right? So why not give and demonstrate that you've done this work, get credit for the work that doesn't necessarily fit into the existing assessment frameworks by leveraging instrumentation, logging, and other things that you can get from using the cloud combined with OpenShift. So building a secure development enclave in AWS, this is one of the really neat things that the System Center out at SPAWAR has done in Pacific is they've built a secure cloud brokerage. And there's a session later today on this. I can't remember exactly when it is, but if you want to see us after, we'll get you that info. But really what they've done is they've taken a cloud environment and they've built this inheritance model where people who bring their applications to the AWS GovCloud enclave that they've built can inherit hundreds of NIST 853 controls just by leveraging AWS and leveraging the OpenShift container platform. And this is all work that Amazon Web Services and Red Hat have done on your behalf to make your lives easier. You don't have to worry about inheriting somebody's old accreditation, that's DICAP instead of RMF. You don't have to worry about implementing a lot of these different enterprise controls. We take care of all that for you. And then the System Center has also accredited their environment for developing software securely. With AWS, you can host information now all the way up to Impact Level 5. And if you're not familiar with the DoD impact levels, it's basically a way of the DoD classifying information that is being put into the cloud. So Impact Level 5 is the highest level of classification of unclassified data, which is a weird way of saying that. And basically it means a national security system. So there are national security systems that run inside of AWS today. There are some that are publicly referenceable as well you can find if you wanted to do some reading about them. But from IL5 all the way down to IL2, which is public, right? Then we also have our classified offerings. And one of the neat things about this pipeline and this partnership that we have with Red Hat is that when you build these systems, when you build these pipelines, they're all the same, no matter what classification level you're working at. So if you have college kids working in Starbucks in the US East region, developing containers that are being pushed through an OpenShift pipeline, they take that code, they send it to the System Center. A developer who's in an accredited enclave then takes that code in, runs it through the same pipeline, and then maybe even deploys it up to a higher level. All of this process has not changed. All of the automation stays the same because you're using consistent infrastructure in the cloud. You're using a consistent platform for building and managing your applications in OpenShift. So some of the benefits that we've seen from this cloud brokerage experiment and that we're using with OpenShift as well is the ability to experiment in pre-accredited enclaves, and you're up and running in minutes. Once the brokerage gives you an account, you have access to use AWS. You have access to spin up instances. You have access to spin up OpenShift databases. One of the really interesting integrations with OpenShift we have is something we call the AWS Service Broker. So instead of giving all of your developers access to the AWS console to create services, you might give them access via the Service Broker, and their application in OpenShift will actually declare what AWS resources it needs, and it will go and create those for you. Through the extensibility of OpenShift, you can also integrate with other services. So maybe for the dev column of what Phil was showing us earlier, I might be using Amazon RDS to create databases rapidly, clone development environments, snap things over. But as I move further into my QA and certification cycle, I might start using something that has a little bit more fidelity to where I'm going to deploy in production, especially if I'm going, say, to a ship or to a mobile or a platform that might have disconnected operational capability. You can deploy 1, 10, or 100 nodes instantly. One of the really revolutionary things about the System Center Cloud Brokerage is their acquisition model, which is surprising, right? Acquisition. But it's awesome because they really worked hard to build a flexible model for programs to come in, provide them funding, and start using cloud services without a big acquisition hurdle. The breadth of functionality, so our managed services, our service broker with Red Hat, that's a huge benefit for customers. You get access to managed databases. You get access to the container platform with OpenShift. You get access to compute across all different types of compute, GPU-based, high performance, dense core compute. So as you're starting to build applications and you're starting to experiment, maybe you're starting to look at ways that you can collate data faster and classify it quickly so you can use it for machine learning training or something like that. All of the services you need to do that mission are available for you today in GovCloud. Most of them are accredited for DoD use. Some of them are still in process, but we're rolling out new services constantly there. And then finally, it's the cost, right? So one of the things that's kind of a huge driver of why we feel this is such an advantage to the DoD is that you can fail cheaply, right? I don't have to go out and spend $500,000 on hardware, standing things up, building a lab, accrediting it, stigging it, getting it all ready to go, and then find out it doesn't work for me, right? I can quickly and easily push some code into an Enclave, spin up in a very automated fashion an OpenShift cluster, and test my application. I can leverage the infrastructure that's being provided to me by the System Center very rapidly, very quickly, spin up, test my application. And if it doesn't work, what am I out? A few $1,000s in AWS charges, and I move on to the next thing. You know, I think one of the really interesting things Admiral Barrett said about compile to combat in 24 hours was that she wants to establish the App Store for the US Navy. All right, so you think about your iPhone. I have applications on my iPhone. My kid installs applications on my iPhone. I don't worry about security vulnerabilities, right? I don't worry about malicious software because Apple has a very stringent set of rules that you have to follow to get into the App Store. You have to write your code a specific way. You have to release memory correctly inside of your application code. And they scan all that. They put it through a pipeline very similar to what Phil just demonstrated to you. What's the benefit of that? It's harder for me in some ways, right? I have to change the way that I think, to change the way that I do things. But what's the benefit that I get from that? I get access to the largest mobile user market in the world, right? So as you're building these projects, and as the Navy's program offices and their contractors and partners are building these applications, they have the ability now to take advantage of this framework, take advantage of the tools and the benefits that are being provided. They have to follow the rules. It might require some reimagining and reengineering, but think about the speed and the agility they'll be able to get, how much faster they'll be able to deliver capabilities to the fleet. So that's all I have. It looks like we got done a little faster than we thought, so I'd be happy to open it up for questions for Rick, Phil, or myself. All right, well, we'll be hanging out after if you guys want to chat with us, so thank you very much.